Welcome to the Cisco Netacad CCNA Introduction to Networks video series by Jason Johnson. This video is Chapter 4, Network Access. The material in this video covers the 6.0 version of Cisco Netacad CCNA Introduction to Networks course. Thank you for watching the videos. Your time is appreciated. If you find the material helpful, you can subscribe to my channel, and remember to click the notification button if you want to see when I post new content. If you have any questions, you can leave a comment below. And if you watch to the end of the video, I'll have links to the next chapter. So let's take a look at Chapter 4 and what we're going to be doing. In Chapter 4, we're going to be looking at the physical layer protocols. We talked about protocols in Chapter 3. Well, we're going to be talking about the physical layer protocols in Chapter 4. We're going to be looking at network media, the data link layer protocols, and the media access control. So in Chapter 4 and the first one, 4.1 physical layer protocols, we are going to identify network types of connections. So when we talk about the physical layer connections, we're talking about how do we transfer data from one endpoint to another endpoint or from an endpoint to another device. So the different types of connections we have. This is a Cisco wireless router here, or a home router or SOHO router. You have your Ethernet switch here where you have you can plug in your Ethernet. You have your internet connection here where you put your WAN port. You have your embedded wireless antenna. It doesn't actually pop up. The one I have a Cisco, a little more newer Cisco, and it's got the antenna that kind of comes up like that. Some of those have that. You connect from your Ethernet to your end device so that you can your internet or your WAN comes into your port there. It gets processed through, and then on your switch side here, it gets sent to your end device so that you can have internet connection. Or you can use wireless as well, and broadcast through a wireless card. So the network interface card, or you'll hear the term NIC, N-I-C, NIC. That's a network interface card, and in the industry we just call it a NIC card, which is redundant. We just call them NICs. That's a network interface card. And so you can connect in a lot of different ways. You can plug in a Ethernet cable through an RJ45 connection here, or you can use wireless routers. You can use also, and we talked about this in a previous chapter, you can put range extenders, or you can plug those in so you can get, this picks up the signal, this range extender does. It picks up the signal from the router and then passes it on to devices so that if you're not getting a signal far enough, you can put those in place. Okay, and well, if I can get moved on to the next slide here. So the purpose of the physical layer is to accept a complete frame from the data link layer. So the physical layer is we accept a full, and I ended up getting my pen messed up there. So the physical layer accepts a complete frame from the data link layer. It encodes it. Remember the encapsulation and de-encapsulation process. It encodes it as a series of signals that are transmitted onto the local media. So it encapsulates it and it sends it down, and this is a signal here, and it's going to do ones and zeros, and so it has a kind of a cutoff line here, and so after that signal drops below a certain point, it says it's off then. So that signal strength goes up and down, and then it goes to the physical layer media, and you can describe the physical layer media types here by you can have either Ethernet, which is your copper. You can have fiber optics, which is your light emitting, or you can have Bluetooth transmission. You can have wireless transmission through Wi-Fi, and there's a few other ones too, and you can look those up in your reading for Chapter 4 in the Netacad course. And then we have standards in place for physical layers. So the standards organizations, we talked about those in Chapter 3. In Chapter 4, when we're talking about here with physical layer standards, you have those organizations that say if you're going to do a physical layer, or that information, there are standards in place that says they have to meet these certain specifications. So an Ethernet has to have X amount of wires, and it has to be a certain diameter, and it has to be able to carry a certain amount of signal, and so forth. So those standards are set forth in that. Now the physical layer characteristics, you have the functions of the physical layer, you have the physical components to it, and then you have encoding and signaling. And those that's the function of it. The data transfer is another function of it. The data transfer is impacted by the bandwidth, and the term bandwidth just means the capacity to a medium to carry data. And I always use the term of a highway or a road, and I hope that's a good analogy here. But I think of the road as, let's say that if you have a small bandwidth, you may have a 2-lane road. with traffic going both ways. And if you want to increase your bandwidth, you add more lanes to that highway. So you may have a 6-lane highway where you have 3 lanes on each side, or you have 3 lanes or 6 lanes of traffic that you can send data back and forth. And kind of think of that as your bandwidth. That's the size of your medium that you can transfer data through. Now your throughput is a little bit different. That's the measure of the transfer of bits across the media. So your bandwidth is how much capacity you have. Your throughput is the actual measure of the transfer of bits. That's the actual throughput of the data that's actually being sent through. Now you have different types of physical media. Again, you have Ethernet. You have different ways to connect, and you want to look those up in your reading as well. We're just going to kind of briefly talk about those, or just kind of touch on those in the point here. Now let's take a look at 4.2 network media. With the network media, we have copper cabling, and that's one of the most common in networking. And the reason it's so common is because it's inexpensive compared to other types of media. Fiber optics is expensive, where Ethernet or copper cabling is inexpensive. It's inexpensive, it's easy to install, it's low resistance to electrical current, which is a big plus, so that you can lay it not right up next to high voltage, but you can get it closer to electrical lines and not be impacted as much. The distance and the signal interference is also a good characteristic of the copper cabling. You have pretty good distance with it. And depending upon which category of Ethernet you have or which category of cabling you have, it's going to go different distances based on whether it's a coax cable or an Ethernet. And then you have different terms here. You have the copper media on the inside, so you have some type of copper that transfers the electrical signal. And then we have different terms that you just need to know these. You have unshielded twisted pair. Now, unshielded twisted pair and shielded twisted pair. Unshielded is going to be less expensive, and shielded twisted pair is going to be more expensive because you've added some extra material in here. We've got the shielding that goes over the wiring. The reason we do that shielding, let's say for example you're going to have copper, you're going to be putting in cabling and you've got to put it in next to some high voltage lines, or you're going to be putting it in next to some lights that are going to be causing some interference. Or you're going to get some kind of interference from some type of electrical interference. So we have to put shielded twisted pair in so that interference doesn't impact the data being sent through those copper cables. And because it's shielded, it's going to cost you more. So unshielded, cheaper, but it's also more susceptible to interference. Shielded is when you have to have cable that's not going to be interfered with, and it's going to be a little bit more expensive. Coax cable, if you've got cable to your house, in the United States, there's a lot of homes that have coax to their house. Cable companies will run coax because it's less flexible than the Ethernet, the Cat 5, Cat 6 cable. However, it is more durable. And you can see here from the picture, it's got a plastic coating on it here, and then it's got this copper mesh here, which helps shielding. So that copper mesh is, if you look up Faraday cage, F-A-R-A-D-A-Y, Faraday, if you look up Faraday cage, you'll see why they mesh this copper here, because that does keep out the signals. If interference, it keeps that out. Then it's got this plastic coating here. It's got some more metal here, shielding. It's got this plastic here, and then it's got the copper line on the inside. It's larger. This copper line here is much larger than the different pairs of wires that are coming in here. So it's less bendable. It's less flexible. You can't take it around corners the same way you can Ethernet cable or Category 5, Category 6 cable. But it is more durable. And that's why they use it more for outside homes and things like that. So when we're talking about copper media safety, though, you want to be careful about fire and electrical hazards, because even though you're not going to be electrocuted by these wires, by the signals that are sent across the network, it is still, you could be working around electrical outlets and things like that. So you just want to always keep safety in mind when you're working with cabling and putting cables in place. Now, unshielded twisted pair cabling, excuse me, with the properties of the UTP cabling, it cancels out EMI and RFI signals with the twisted pair. That's the unshielded twisted pair. They twist these wires, and so you have Category 5, Category 5E cable. That's an unshielded twisted pair. The UTP cabling standards are TIA, EIA 568, A or B. The IEEE sets the standards for Cat 5, 5E, 6, and 6E. You have unshielded twisted pair connectors, and they'll look very similar. They'll look like that right there. You take the wires and you plug them in, and then you crimp that down. And you have different types of UTP cable. You have rollover, crossover, and straight through. Those serve different purposes. What I suggest you do is going to the reading for the Netacad course that you have in there, and it's going to talk about the different purposes. I just don't have a lot of time here in this presentation to talk about them, but they are different depending upon how you put the wires through. So depending on how the signals get sent through, whether it's a rollover, a crossover, or a straight through. Now you can also test unshielded twisted pair cables, or you can test those based on the cable pinouts. I have a device that I can plug this point in, and then I've got another little small cable that plugs in on the other end, or I can plug both ends in, and it will send a signal through the wire to tell me, is it wired properly? This is the T568A, and this is a T568B. And when you do, whether I need a rollover, a crossover, or a straight through, that device is going to tell me, did I get that proper wiring done, and did those signals get sent through on the wires? 1 wire, 2, 3, 4, 5, 6, 7, 8, and is it correct on both ends? The fiber optic cabling is, you're probably not going to be working with fiber optics as much, but you do need to understand the concept of it and understand it. If you do go into working with fiber optics, it's a good area of the networking field to be in. Fiber optics allows you to transmit data over long distances. I mean, much longer distances than regular unshielded twisted pair Ethernet. It's flexible, but thin strands of glass, so it can be broken, so you have to be careful when you handle it. It transmits with less attenuation, which means it has less signal loss over a greater amount of distance. And it's immune to EMI and RFI. So it's immune to electromagnetic interference and radio frequency interference. So it's immune to those. However, you want to be careful about it, though, because of the properties of it. If you do break, if you've got a bundle of fiber optics cable, it takes special tools to reconnect those back up. And so you have to get in it, and it just takes a little bit of time, and it takes a lot more time, and it's a lot more skill involved in getting those and connectors getting those back up. So if you cut an Ethernet cable, it's pretty easy just to take those pairs of wires and connect them back in. Fiber optics is much more difficult. The types of fiber media, single mode and multi-mode. You have fiber optic connectors that go on the end. You can also test fiber. There's special tools to test the fiber optic cables. And when we talk about fiber versus copper, fiber optics is much more expensive to use. So that's why you usually typically you're going to see fiber optics run on longer distances, also maybe between buildings. So if you're connecting two local area networks together, you may see fiber optics go between those buildings. You might see a city have fiber optics be put in. And then when you get to the local building or the local area network is where you might use copper or for the local area network. And we have a comparison down here in this chart here. So bandwidth supported from UTP up to 10 gigabits. On fiber optics, it's from 10 megabits all the way up to 100 gigabits. Distance about 100 to 100 meters. For fiber optics, it's 1 to 100,000 meters. Immunity on the UTP is it's not immune. It's very susceptible to EMI and RFI. You have completely immune on the fiber optic side and completely immune to electrical hazards on that side. You're not immune on the UTP side. And the cost, though, see your cost here, cost, skills, and safety precautions are much lower than you have to have on your cabling on your fiber optic side. Now, when we talk about wireless media, the properties here that we're talking about, data communications using radio or microwave frequencies, your distances are much smaller or much shorter on wireless media based upon what you're using, whether it's Bluetooth or Wi-Fi. Bluetooth is much smaller range than Wi-Fi. There are different types. You have Wi-Fi, Bluetooth, WiMAX. There's some other ones out there too, and you'll read about those in your material in your chapter. You have wireless local area networks, and you might have a device like this that you set up. You have your WAN come into it, and then you broadcast out, and your different devices pick up that signal and then can connect to the internet or your network based upon that if it has the right protocol set up. So if you have Wi-Fi set up, let's say on a mobile device, and you can connect to that device there and get signal. And we call these a WAP or a wireless access point. You'll hear the term WAP or WAP. Well, that's a wireless access point where you broadcast out on there. And then you have wireless NIC cards, wireless NIC adapters. You can put a wireless NIC adapter. Most laptops in 2017 have wireless NICs in them, so you can receive that. But some of the older ones did not, and you would have to plug those in, and they would receive signal from them. Okay, so in 4.3, the data link layer protocol, the purpose of the data link layer protocol is what you want to do is you want to look up what the layer is responsible for. It's really, there's two different link sublayers on there. It is for connecting. You have the LLC, which communicates with the network layer, and then you have the MAC, which defines the media access process. So if you have, and this is the layer 2, and you want on the OSI model, and the MAC address or the MAC defines the media access processes. So when you hear the term MAC address, that's at this layer of where at the data link layer is where that information is processed. So it provides access to media, and there are data link layer substandards, IEEE, ITU, ISO, and ANSI. And then in the previous chapter, we said what are some of those standards out there. Well, these are some of the standards and organizations that are out there: ANSI, ISO, ITU, and IEEE. You can look those up on the internet on what those are. Now, media access control. When we control access to the media, what we're really talking about is the topologies, or when we talk about topologies, we have your physical topology and your logical topology. Our physical topology is when we're saying what is the actual equipment. So when you design this in Packet Tracer, or you're actually laying this out in some type of a design software, you're going to have your physical topology laid out, and it's going to say, I've got a server here, I've got a switch here, a router here, and it's going to give, it's going to show where everything is, and it's going to label everything, so you're going to know where it is. Now on the logical topology, you're gonna have these two topologies. They're gonna match, but over here we're gonna say this kind of I'm matching this part right here to this right here. So you're saying that we're gonna have switch 1. See, switch 1, it matches up, but over here we're actually listing out which connection it's tied to. So this one is F01. Up here we're giving our IP address. Over here, we're saying this is on G00. Up here, we're giving our IP address for that subnet. We're giving our V4 for that subnet. We're not giving out all the IP addresses. We're just saying this is the subnet IP range here. Over here, see, we didn't do that. See, this is room 3 over here. We didn't have that segmented out. So you have two different topologies. One is physical, one is logical. And they serve two different purposes. Now, when we talk about WAN topologies, the common physical WAN topologies are point-to-point, hub and spoke, and mesh. And you're gonna go in your reading, and you're gonna learn about different ones in here, where we have the star topology, you have your mesh topology, you have your point-to-point. You want to read up on those. When we talk about the different ones, this is a star topology here because it looks like a star, or you've got a central location with all of the spokes coming in. You have your point-to-point, and that might be where you just have two devices connecting to each other. And then you have a mesh topology. And a mesh topology is when you would have redundancy put in place. And we talked about redundancy in a previous chapter. Well, redundancy would mean, let's say that this connection gets knocked out. Well, now this device, instead of having to go through here to connect, can now connect just directly through. Or it can connect over here and back this way. So mesh is more expensive to put into place because you have more wiring in place, or you have more media connecting it. But it is more redundancy to it. Now, some of the LAN topologies that you, or some of the terms that you're gonna need to learn. Your physical LAN topologies, you're gonna do those in the reading. Those are your star topology, your bus topology, your hybrid topology. This is a ring down here. This is ring topology. This is a hybrid because you have a star and you have a star, but they're connected together. So that's a hybrid. That's a hybrid on there. And so you're going to have some other terms that you need to do on your reading is half and full duplex, and that's how the signals are being sent. And then also contention-based access, the CSMA CD versus CSMA CA. Those are important terms. I'm not going to talk about them here in this video, just based on because of time. But you do want to look those up in your reading and what the CSA. Let me put it this way: you're going to have questions on those. On the CSMA CD and the CSMA CA. You're going to have questions on the exam and the final exam in this course over that. Now, the data link frame, when we talk about the data link frame, the frame consists of the header, the data, and the trailer. So you have your header, your data, this is all your information here, and your trailer. Your header is just your information that says, here's the frame start, here's where it starts, here's my addressing information, here's the type of information, here's your control, here's all your data. This is your error correction or error detection. Were there errors in the data? Was the correct amount of data sent? And then you have your frame stop that says, okay, here's the ending point. And that's it. These two are included in the trailer. These two are included in the header, and then that's your data in there. And on the LAN and WAN frames, it's controlled by the 802.11 wireless frame. So if you look up the 802, the 802 is controlled by that, or you have the PPP frame, the HDLC frame relay, and Ethernet frame. So they have different types of frames in there, and you want to read about those in your material. Okay, so in Chapter 4, we have looked at how the physical layer protocols and services support communications across the data network. We looked at building a simple network using appropriate media, whether it's copper or fiber or whatever media we're using, or wireless. Explained how the data link layer supports communications across data networks, the layer 2, and then or the layer 1 and the layer 2, and then compare media access control techniques and logical topologies using networks. And so that's going to conclude Chapter 4. I hope this material was helpful, and I hope you have a great day.